We are Unam Space, a group of different students with the same goal, to show the world that we are able to compete in the University Rover Challenge.
The power and electronic system was designed to supply necessary energy safely to actuators and to systems of our rover, in addition to maintaining electronic communication between them. To accomplish this task, we have developed three 12-volt lithium-ion battery packages and designed a power distribution PCB that regulates voltage and distributes it to other components. We have also developed PCBs based on STM32 and Arduino microcontrollers that integrate the speed and direction control stage for DC motors on wheels and stepper motors for corner steering, including the communication stage.
The communication system operates in the ISM frequency band. A 2.4 GHz NRF24LO1 transceiver located inside the rover is used to send commands, control the rover and electromechanical arm, as well to receive telemetry.
This transceiver is remotely manipulated by means of a control integrated in the same module. Both transceivers use omnidirectional antennas for signal transmission, adapting even to terrain where visual link is not feasible, as the case of the Utah desert.
As part of our future plans, we intend to enhance our communication system.
This will include the successful implementation of Ubiquiti access point connection, enable the addition of IP video streaming, and IFB camera integration.
The camera subdivision is in charge of the interior and exterior vision of the rover. Regarding the main task of the subdivision is to be able to give the science team a vision of the environment with a panoramic image and to locate the rover through GPS, integrating them in the images, in addition to send clear image of the samples obtained in the later analysis on the ground station. Also, the inter-real vision camera will be used for autonomous navigation with a point cloud, which will collect data and send it to the computer to understand the environment.
The software division is responsible for controlling, communicating, and transmitting data from each of the other systems that make up the rover through the Intel NUC i3. The navigation system consists of a non-deterministic algorithm that allows it to take direction towards the goal, while exploring and learning from its environment. Similarly, the robot remains in constant communication with the local station through a telecom system, which can take control of it at any time while receiving and displaying real-time data, such as acceleration, direction, location, and data from the science division's experiments. Our software has been developed to run on any Linux distribution in the most secure and efficient way, while maintaining a relationship of low coupling and high cohesion, which allows it to be maintained and improved in minimal time.
In the scientific mission, we utilize a robotic cam to assist in the collection of samples using a salt core sample. These samples are then securely stored in a rack container separated from the scientific module to prevent any risk of contamination. We will also integrate a salt sensor into the rover suspension to measure in situ temperature, conductivity, humidity, pH, nitrogen, phosphorus, and potassium.
In addition, we have a Raman spectroscope that will help us identify the chemical structure of the sample, as well to identify biological important molecules such as lipids, amino acids, porphyrins, and extremophile organisms.
We examine the color, texture, and grain size of the samples in mineralogical geology under a microscope to provide detailed geological and paleontological descriptions with LED lighting enhancing visibility. We also include sensors that provide real-time readings of parameters such as temperature, relative humidity, and atmospheric pressure.
Our Walker buggy suspension is made of galvanized steel tubes, so it can withstand the total weight of the rover. It has ABS 3D printed parts in each union with the intention of making manufacturing more accessible for our budget, but without compromising mechanical properties of the materials. We also opted for a corner steering system for improved maneuverability.
The arm system is an essential part of the rover configuration as it is responsible to performing multiple tasks. The external structure of the arm is made of MDF and consists of articulated segments with motors for precise movement. We plan to improve and finish this design with 3D printing and aluminum. On the inside, the arm has a change and a set of gears that are the elements that allow us an optimal transmission of movement. We implemented arrays that allow us to rotate 360 degrees to have a better manipulation of objects. Our goal is to implement claws that can be interchangeable to accomplish the different missions of the URC competition.
This year, we built the main chassis out of aluminum alloy profiles in order to make it lighter, easier to assemble, and with the possibility in the future for changes or modifications. The design allows for different models to be attached for each individual mission, while still being within the total weight limits. As a result, we optimized the 2024 chassis total cost in comparison with last year.